Hello guys, welcome back to Baritoni's Projects. It's been a while because I've been designing this monstrosity as you've seen here. Last video I explained this, I believe. It's my electronic firing system for the 4th of July, which is coming very soon. It's like the months are really ticking by, so I really have to hurry things up. So in this video I will be explaining how this works and why I chose this over this. Thank you. So, in the last video, I think I explained this. It's the firing system. I believe this thing has 12 MOSFETs, which I use to control the E-matches, which I plug in here. So there's a couple problems with this. Number one, E-matches would get stuck in these. I don't know if you can see, but they're kind of breaking. As you can see here, it broke these, which is not a hard problem. Number two, why did I switch to relays instead of MOSFETs? Well, relays are mechanical and a lot easier to understand. On AliExpress, MOSFETs and relays are about the same price. Depends if you buy them individually or in like channels right here. These are 8-channel relays. This one also has 12 MOSFETs. This one has 24, so big increase. Yeah, so relays are mechanical. I can understand them easier, and in the future, sorry, had a bad cough recently. So in the future, I was planning to make my own channel relays instead of buying them off AliExpress, so I can combine the motherboard with the Pico here and have all of this in one board, and then just attach it to this and put it on a piece of wood like you see here. Also, I bought these switches. I know they're kind of out of frame, but these switches, they're cool, like, you know, Doomsday switches or whatever. They're like really cheap, so might as well. Powering the Pico is 2 AA batteries here, and the relays is a 9-volt battery, which is going to be firing the actual. That's the electricity that's going through the MOSFETs. Not MOSFETs, the relays for the E-match. In the future, when I'm designing it, I want to have 2 of these wired up. I forget if it's in series or parallel, which doubles the amperage. But I think the batteries I have right now is like 500 milliamps for 9-volt batteries. So I want to get that to 1 amp so I can really make sure I'm lighting the E-matches. Even though I do light with, you know, the 9-volt 500, I looked it up on Google and 1 amp is ideal. So I was going to switch to that as well. Number 2, I don't know if you've seen this or you've looked at firing systems before, but usually when you plug in the actual E-match, there's like a, sorry, a sec, I'll grab one. Nice. I don't know if you guys have seen this before, but when you actually plug in the E-match, this is like a Red Dragon igniter. Where's the end? When you actually plug in the end into the, what is it? I think it's the audio speaker port or whatever. It's on the thing. There's a little LED that lights up saying that you have continuity. And I was looking online on how to build that into a PCB, and pretty much it said you want to run very, 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 very little current through this to show that the electrons do have a path to go light up the LED. So I'm going to try and add a continuity tester for each single, what is it called? 5-pin to 5mm 2-pin screw terminals here to make sure that these are really connected. I want nothing to break on the 4th of July. Nothing. Not a single thing. I'll make an LED for every single thing so I know how to diagnose like any problem pretty much. I'm going to show you guys how the system works. So I have Raspberry Pi Pico. It's a regular one. It's not a W. There's no chip here. I just have a program that goes up each relay firing them. You'll hear a little click, you know, since it's a relay. And on my multimeter here, you should see a spike up to 9 volts. At least that's what it should be. So I'm just going to like put my things here, go like boop. See that? And it should spike like this. Top one is for the 9-volt battery thing. You can see it down here. If I can show it to you. There's a little, module here where I have the 9-volt, and this is the Pico power right here, which is on this switch. So let me switch on the 9-volt. Excuse me. Get my things untwisted. I'm going to switch on this. There's a little LED that lights up. Should it click? Spike. Yeah. And you can see like that. And let me just show it for you guys again. I know these jumper wires are in the way, that's fine. But you should hear the red LED go right here. If it'll work. Hello? Nothing seems to be. Give me a sec. I hope I didn't short anything, but with all these loose wires laying around, I wouldn't be surprised. Did the thing break? Oh, I think the thing broke. Yeah. Where is it? Yeah. Right here. The wire just snapped. Give me a second. Figure out which thing on the back should be a quick fix. Where's the green? Should be the bottom one. Blue goes to there. Black. What on earth? Yeah, here it is. Okay. Sorry about that. Okay. Quick fix. So I'm going to turn it off. Should we get a green LED? Yep. You guys can see that. And you should be able to see the red. Yeah, like that. Then you hear the clicking. Yeah, just like that. So that's how this thing works. In the future, maybe in like a month or so, I should have a PCB with the 24 relays like this built into it with a continuity tester on the actual thing itself. Then I should have the Pico right here as well, motherboard built into that too. Anyway, thanks for watching today's video, guys. I will leave my website with, I should have a post about this built into a more detailed description. So thanks for watching, guys. Have a good day.